This is a quick lesson about the chemistry PACE 1125, and we're going to look at page R, and particularly question 25 on that page. And if you look at that, it should see this problem right here. We want to talk about the steps that are involved there. The point is that if an equation is balanced, no mass can be gained or lost. So all the mass that would be present on this side, which is the reactants, should also be present over here on the product side. Now we'll have to, they'll be recombined, as you can see, but we're going to figure out what the mass is of each of these four compounds, and then the total mass here should equal the total mass over here. So we're using a periodic table, and the one that you're using might be just slightly different. For instance, on here for barium, it says the mass is 137.34, and I see that in the score key it says the mass of barium is 137.33. So the mass of just barium is 137.33. Now let's figure out what the mass is for H2O. Oxygen is 16, and hydrogen is 1.008, but I have two of those, and so we can add these up. So water would be 18.016 for one molecule of water, but notice I have two, so I'm going to multiply times 2. And for this, the whole thing becomes 36.032. All right, now let's do the easy one, hydrogen over here. So the total hydrogen is 1.08 times 2. So this is going to give me a mass of 2.016. Now we've got to figure out what the mass is of this molecule. And this is the most complex. I actually have two, because it's kind of like distributive property, like you do in Algebra 1. So we're going to distribute the 2 times oxygen, 2 times hydrogen, and then add the barium. So let me do that. We'll do that down here. So 137.33. And then oxygen is 16, but I have two of them, so I'm going to go ahead and add 32. And then I have two hydrogens, so I'm going to add 2.016. And just add these up. And let's see here, 171.346. And if we were to add these, we should end up with 173, okay, 0.36. So basically dropping that little 2 out there. And then if I add these together, also 173.3, round that up to 36. So here's the key. If this number equals this number, then we say the equations are balanced, all right? And so that's one way of looking at it. The masses have to be balanced, and that's what they actually want you to do for this problem. And then when you turn the page and are doing all of the problems here on page S, you're going to do the same thing. Write the molar mass of each of these, add all of the reactants together, get their total mass, add the mass of all the products, get the mass, and then when you add them together, they should be equal. If it's off by just a teensy bit, you know, and if you rounded it just a little bit, it was the same, then you're fine. Okay, give yourself credit, and it may not be exact depending on the periodic table that you're using and how you round it. But that's how you do all the problems on page R and S. And we'll do another video and talk about some things on page T.